In this video, I will discuss the JEE Advanced PYQ from the topic waves. This question is based on Doppler effect of sound waves when both the source and the observer are moving. There is a source emitting sound waves in all directions, and there is an observer here. Let the frequency of the sound which is being emitted by the source be Fs, and when this sound reaches the observer, let the frequency be F OB. The observer can move, say, with a velocity VOB, either towards the source or away from the source. Similarly, the source can move towards the observer with some velocity, say Vs, or it can move away from the observer with some velocity Vs. So when both the source and observer are moving, the frequency of the sound and the frequency of the sound received by the observer will be different by a factor c plus or minus velocity of the observer divided by c plus or minus velocity of the source. This formula, which relates the frequency of the observed sound with the frequency of intrinsic sound, is called Doppler formula. Plus and minus sign can be decided based on physical reasoning. If the distance between the source and observer is decreasing, then the observed frequency will increase. If they are moving away, then the observed frequency will be less compared to the source frequency. So if the observer is moving towards the source, you put a plus sign here. If it is moving away, minus sign. If the source is moving towards the observer, frequency will increase. To increase the frequency, the denominator has to be less. So put a minus sign here. So if the source is moving away, then the frequency has to decrease. So you have to put a plus sign here. But instead of source and observer moving along the line joining the source and observer, it can move in any other direction. It's not necessary to restrict the source and observer to move only in the direction along the line joining the source and the observer. Suppose the observer is moving in this direction, say at an angle theta, with the line joining the source and the observer. Similarly, the source can move at some other direction with velocity Vs, which makes an angle, say beta, along the line joining source and observer. So in this case, how will the formula get modified? Here also the observer is approaching the source, because the distance between the source and observer is initially this much, now it has decreased to this much. Similarly, the source is also approaching the observer because it's moving towards the observer. But so in this case, I have to take the component of the velocity along this direction. So I have to put cos theta here. VOB is like this. So VOB cos theta is along the direction joining the source. Similarly, source has a component cos beta along the line joining the source and the observer. So I have to put cos beta here. Okay, here in this case, both are approaching each other. So you have to put a plus sign here and minus sign here. But if the observer is moving like this, then it's moving away from the source. So you put a minus sign here. Similarly, the source can move like this. Okay, then frequency is going to decrease. So you have to put a plus sign here. So with this understanding, you can solve this JEE Advanced question. This is the question. You can read it. A train S1 moving with uniform velocity 108 km per hour approaches another train S2 standing on a platform. An observer moved moves with uniform velocity of 36 kilometers per hour towards S2 as shown in the figure. Both the trains are blowing whistles of same frequency 120 Hz. When O is 600 meters away from S2, the distance between S1 and S2 is 800 meters. The number of beats heard by O is dash. This is the figure. Source 1, source 2. This is a moving train, stationary train. Both are blowing whistles. This is the observer moving in this direction with this much speed. So the observer heard two sounds, one from S1 and one from S2, and they will interfere here to produce beats. So to find the frequency of the received signal F1 and F2 using the Doppler formula, and then find the difference. You can pause and attempt this question. So let F1 be the frequency of sound received from S1, and from S2 let the frequency of sound be F2. And the frequency of the sound emitted by the train, let it be F0. So F1 and F0, they related by the Doppler formula C plus or minus velocity of observer, and we have to take the component cos theta and C. Observer is, source is moving like this, so distance between source and observer is decreasing. So source will contribute towards increasing the frequency. Vs into cos beta. Observer is making an angle theta. So this angle is theta, and source is making an angle beta. Okay, and source is moving towards observer, so we'll have a minus sign, and observer is moving towards the source, we'll have a plus sign. Both the movements are contributing to increasing the frequency. Observer is moving towards the source when it goes up, and source is moving towards the observer when it goes like this. And this triangle 600, we have the standard triangle, right angle triangle, 3, 4, 5. So if I multiply this 2 by 2, I'll get 6, 8, 10. So for this triangle, this angle is bigger angle, 53 degrees, and this smaller angle is 37 degrees. This is 90 degrees, and this is a bigger angle because 800 by this one. So theta is 53 and beta is 37 degrees. So use this standard triangle result to get the angles there. So velocity of sound is 330 plus velocity of observer 36 kilometers per hour. So this 330 meter per second. So 36 kilometers per hour. If I convert to meter per second, it will be 36 into 1000 per hour. So per second will be less by a factor 3600. Kilometer to meter will get multiplied by a factor 1000, will become more. Per hour, this much per second will be less by a factor 3600 because 1 hour there are 3600 seconds. So this is 10 meter per second. This is velocity of observer. And velocity of the train, that is Vs1, that is the first train. It's 108 kilometers per hour. So to convert to SI units, same factor, multiply by 1000 per second will be divided by 3600. 9 fours are 36, 9 ones are 9, 12, so 3, so it is 30 meter per second. So that is Vs1. So 30 meter per second, and cos theta is 6 by 10. This is 1000 by Pythagoras theorem. 600 square plus 800 square is 1000. Or 6, 8, 10. So 6 into 100, so 10 into 100 is 1000. So cos theta, it is 3 by 5. Sound speed 330 minus velocity of source is 30. This velocity of observer, it should be 10. Numerator is observer. Denominator is velocity of sound source 1, 30. Into cos beta is this one, 4 by 5. So this is 330, 336, 2 times, so 6. This is 6, 330 minus this one is 24. So 306. This is F1. So into F0. This into F0 is F1. F0 is a source frequency 120 Hertz. Now to find F2, F2 is again C plus velocity of observer in the direction of the source S2 divided by C minus velocity of source 2 and cos of angle. So for this second sound, observer is moving towards this thing, but in the line direct joining the this one. So there is no component. The full component is 36, which is 10 meter per second, and the source is not, S2 is not moving. S2 is stationary train, so Vs2 is 0. Only observer is moving with the velocity of 10. V with respect to S2, which is 10 into F0. This is 10. C is 330, so 340 by 330 into F0. So beat frequency is difference between F1 and F2, which is 34 by 33 minus 6 will go 5, 61, 6 will go 5 times. So I can cancel 6 here. 6 will go 51 times. 6 will go 5, 56 times. 6, 5, 30, and then 6, 6. So 56 by 51. So this will be 1 plus 1 by 33. Here also I have a 1, and then 5 by 51. This is 1 plus 1 by 33. So 1 and 1 will cancel. This will be 1 plus 5 by 51. So this is easy way to calculate. F0 is given 120 . So this you have to simplify. Here actually plus or minus, because beat frequency is difference between the two frequencies. So 51 minus 3 times this is 150 plus 50, 165. 165 . 165 . 165 . 165 . 165 . 165 . 165 . 165 . 165 . 165 . 165 . 165 . 165 . 165 . 165 . 165 . 165 . 165 . 165 . 165 . 165 . 165 . 165 . 165 . 165 . 165 . 165 . 165 . 165 . 165 . 165 . 165 . 165 . 165 . 165 . 165 . 165 . 165 . 165 . 165 . 165 . 165 . 165 . 165 . 165 . 165 . 165 . 165 . 165 . 165 . 165 . 165 . 165 . 165 . 165 . 165 . 165 . 165 . 165 . 165 . 165 . 165 . 165 . 165 . 165 . 165 . 165 . 165 . 165 . 165 . 165 . 165 . 165 . 165 . 165 . divided by 33 and 51 into 120. Three will go 11 times. 3 4s are 40. So I'll take the minus sign here, so it will become plus. So this will be 4, 1, 114 divided by 11 into 51 into 40. So this is an approximate or exact calculation. We ask a number of beats. So 51. Let me do an approximate calculation first. So this is approximately, if I do an approximation, say this is 10 times. Okay, so it will be approximately 400 by 50. So approximately 8 hertz. So the number of beats heard by O is, they are not mentioned what type of question. Exact answer is 8.13. So if you want to do the exact question, you can do it. So this is the Doppler formula. Observed frequency related to the source frequency by this factor, plus or minus velocity of observer divided by C plus or minus velocity of source. C is the sound speed. But if the observer is moving at an angle and source moving at an angle, you have to take the component. So F1, the sound which is coming from here. So source component. So this angle is 53. This is shorter distance, 300. This is 400, or this is 600, 800, and this one is 1000. So this angle is shorter angle is 37 degrees, and this angle is bigger angle is 53 degrees. So for this, the observer is moving at an angle 10 cos this angle, which is cos 53, and it's towards, so it will be plus sign. And source is moving towards the observer, and the component is 30 cos this angle, which is 37 degrees. This is 37, this is 53, this is 90. And it's minus sign because source is moving towards the observer. And do the F0, intrinsic frequency. So this is the frequency of sound received from the first string. And the frequency of sound emitted by this S2 will reach this source, observer. And here the observer is moving along the line joining observer and source. So there is no component. The component is 10 only. So 330 plus 10, since it's moving towards it's 10. And source is not moving, so just 330, and source velocity is 0. So difference in the frequency, whichever one is bigger, you have to take that one minus. If you don't know, you just take just subtract and put plus or minus and make it positive. So if you do the calculation, it's 8.13 hertz.